Question 1. The performance metrics show a consistent increase in application response times within a VMware Cloud Foundation 5.2 workload domain. Which of the following diagnostic approaches is the most appropriate initial step to identify the root cause? Option A. Initiate a rollback of recent NSXT configuration changes within the workload domain. Option B. Immediately review application-specific logs for errors or performance warnings related to the affected services. Option C. Provision additional compute resources within the workload domain to alleviate potential resource contention. Option D. Begin by analyzing the performance metrics of the underlying vSphere XC hosts, vSAN data stores, and NSXT network segments supporting the affected workload domain. The correct answer is D. Begin by analyzing the performance metrics of the underlying vSphere XC hosts, vSAN data stores, and NSXT network segments supporting the affected workload domain. Explanation. Scenario analysis. The scenario presents a common challenge in cloud environments, identifying the root cause of performance degradation when multiple components are involved. The professional is tasked with diagnosing an issue impacting application responsiveness within VMware Cloud Foundation, VCF. The challenge lies in isolating the problem to a specific layer or component without disrupting ongoing operations or making assumptions that could lead to incorrect remediation. This requires a systematic approach that leverages VCF's integrated monitoring and troubleshooting tools, adhering to best practices for operational stability and data integrity. Correct approach analysis. The correct approach involves a layered investigation, starting with the most fundamental VCF components and progressively moving up the stack. This aligns with the principle of verifying the health and performance of the underlying infrastructure before attributing issues to higher-level services or applications. Specifically, examining vSphere XC hosts, vSAN data stores, and NSXT network performance provides a baseline. If these foundational elements are performing optimally, the investigation can then focus on the SDDC manager and its management of the VCF environment, and finally on the workload domain and the deployed applications. This methodical process ensures that the root cause is accurately identified, minimizing the risk of misdiagnosis and unnecessary changes to application configurations. This approach is best professional practice as it is efficient, reduces downtime, and prevents the introduction of new problems. Incorrect approach is analysis, focusing solely on application logs without verifying the underlying infrastructure, is a regulatory and ethical failure. It assumes the infrastructure is functioning correctly, which is not a safe assumption. This can lead to wasted effort troubleshooting application code when the actual problem lies in network latency, storage I/O, or compute resource contention within VCF. This approach violates the principle of due diligence and can result in prolonged outages and potential data integrity issues if the underlying problem exacerbates. Immediately reconfiguring NSXT network segments or vSAN policies without a clear indication from performance metrics that these are the source of the problem is also a significant failure. Such actions are disruptive and can introduce new performance bottlenecks or connectivity issues. This demonstrates a lack of systematic troubleshooting and a disregard for the potential impact on other workloads sharing the same infrastructure. It is a breach of operational best practices and could lead to service degradation for other tenants or applications. Attempting to scale up compute resources in the workload domain without first confirming that existing resources are being utilized efficiently or that the bottleneck is indeed compute-related is premature. This approach is costly and ineffective if the root cause is elsewhere, such as network congestion or storage latency. It represents a failure to perform a thorough root cause analysis and can lead to inefficient resource allocation, which is a poor use of organizational resources and potentially violates cost management guidelines if applicable. Professional reasoning. Professionals should adopt a structured, evidence-based approach to troubleshooting. This involves 1. Understanding the reported symptoms and their scope. 2. Consulting integrated monitoring tools within VCF, e.g., vRealize operations, vCenter alarms, and SXT dashboards to gather initial performance data. 3. Systematically investigating the VCF stack from the infrastructure layer upwards, SXT, vSAN, and SXT, SDDC manager, and then the workload domain. 4. Correlating performance metrics across different layers to identify anomalies. 5. Formulating hypotheses based on the data and testing them through targeted diagnostics. 6. Implementing changes incrementally and monitoring their impact. 7. Documenting all findings and actions taken. This process ensures that decisions are data-driven, minimizing risk and maximizing the probability of a swift and accurate resolution. Question 2. System analysis indicates a planned upgrade to a critical VMware Cloud Foundation 5.2 environment is being considered to introduce new features and enhance performance. Before proceeding, what is the most crucial step to ensure the integrity and compliance of the VCF deployment? Option A. Rely solely on the general upgrade documentation provided by VMware for individual components, assuming compatibility within the VCF framework. Option B. Conduct a comprehensive impact assessment that includes VCF-specific compatibility checks for all components, a detailed review of the upgrade procedure with a documented rollback plan, and stakeholder communication. Option C. Implement the upgrade immediately to leverage the new features, with the understanding that any issues can be addressed post-implementation. Option D. Proceed with the upgrade during standard business hours to minimize disruption to the IT team's workflow, without prior notification to end users. The correct answer is B. Conduct a comprehensive impact assessment that includes VCF-specific compatibility checks for all components, a detailed review of the upgrade procedure with a documented rollback plan, and stakeholder communication. Explanation. Scenario analysis. This scenario presents a common challenge in IT infrastructure management, assessing the impact of a proposed change on a critical VMware Cloud Foundation (VCF) environment. The professional challenge lies in balancing the need for modernization and feature enhancement with the imperative to maintain stability, security, and compliance within the VCF deployment. A thorough impact assessment is crucial to prevent unintended consequences, such as service disruptions, performance degradation, security vulnerabilities, or non-compliance with internal policies or external regulations. The interconnected nature of VCF components, vSphere, vSAN, NSX, SDDC Manager, amplifies the potential for cascading failures if changes are not meticulously evaluated. Correct approach analysis. The correct approach involves a systematic and comprehensive review of the proposed upgrades implication across all VCF components and integrated services. This includes analyzing compatibility matrices for all affected software and hardware, understanding the dependencies between components, and evaluating potential performance impacts on workloads. Furthermore, it necessitates a detailed review of the upgrade procedure itself, including rollback plans, testing strategies, and communication protocols with stakeholders. This methodical process ensures that all risks are identified, mitigated, and that the upgrade aligns with operational requirements and any relevant compliance mandates. This represents best professional practice because it prioritizes risk management and operational continuity, which are fundamental to maintaining a secure and reliable IT infrastructure. Incorrect approaches analysis. Proceeding with the upgrade based solely on vendor documentation without a specific VCF compatibility check is a significant regulatory and ethical failure. Vendor documentation often provides general guidance, but VCF has specific integration points and version dependencies that must be validated. Relying on this incomplete information could lead to an unsupported configuration, potentially violating internal security policies and compliance frameworks that mandate the use of tested and validated configurations. Implementing the upgrade without a documented rollback plan is another critical failure. This demonstrates a lack of preparedness for unforeseen issues and a disregard for operational resilience. In a regulated environment, the inability to quickly restore services after a failed upgrade could result in significant business disruption and potential breaches of service-level agreements, SLAs, which may have contractual or regulatory implications. Performing the upgrade during peak business hours without stakeholder notification is a direct violation of professional conduct and potentially regulatory requirements related to change management and business continuity. Such an action prioritizes expediency over the operational impact on users and business processes, leading to potential service outages that could have severe financial and reputational consequences and may contravene change control policies. Professional reasoning. Professionals should adopt a structured approach to impact assessment for VCF changes. This involves 1. Understanding the proposed change and its objectives. 2. Identifying all VCF components and integrated services that may be affected. 3. Consulting VCF-specific compatibility matrices and release notes. 4. Analyzing dependencies and potential interdependencies. 5. Evaluating performance, security, and availability implications. 6. Developing a detailed upgrade plan, including testing and rollback procedures. 7. Obtaining necessary approvals and communicating with all stakeholders. 8. Executing the change during a planned maintenance window with clear communication channels. 9. Post-implementation validation and monitoring. This framework ensures that changes are managed responsibly, minimizing risk and maximizing the likelihood of a successful outcome, thereby upholding professional standards and regulatory compliance. Question 3. Benchmark analysis indicates that a proposed upgrade to a core network service within the VMware Cloud Foundation 5.2 environment is being considered. What is the most appropriate first step to ensure this change is implemented responsibly and with minimal disruption? Option A. Implement the upgrade in a production environment during peak hours to quickly identify any potential conflicts with existing services. Option B. Rely on the experience of the senior network engineer to guide the upgrade process, as they have successfully managed similar changes in the past. Option C. Conduct a comprehensive impact assessment that analyzes potential effects on performance, availability, security, and operational costs, involving key stakeholders and utilizing available VCF monitoring tools. Option D. Proceed with the upgrade immediately, as benchmark analysis suggests it will improve network latency and address any issues that arise post-implementation. The correct answer is C. Conduct a comprehensive impact assessment that analyzes potential effects on performance, availability, security, and operational costs, involving key stakeholders and utilizing available VCF monitoring tools. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of assessing the impact of a proposed change within a VMware Cloud Foundation (VCF) 5.2 environment. The challenge lies in accurately predicting the downstream effects on performance, availability, security, and operational costs without causing disruption. A thorough impact assessment is critical to ensure that the proposed change aligns with business objectives and regulatory compliance, while minimizing risks. The administrator must balance the need for innovation and improvement with the imperative to maintain a stable and secure production environment. Correct approach analysis. The correct approach involves a systematic and comprehensive evaluation of the proposed change's potential effects across all relevant VCF domains. This includes analyzing dependencies, resource utilization, security implications, and operational workflows. By engaging stakeholders, leveraging VCF's built-in monitoring and logging capabilities, and potentially utilizing a non-production test environment for validation, the administrator can gather the necessary data to make an informed decision. This methodical process ensures that all potential risks are identified and mitigated before implementation, thereby upholding best practices for change management and operational integrity within the VCF framework. Incorrect approaches analysis. Implementing the change without a formal impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for established change management protocols, which are often mandated by internal policies and potentially by industry-specific regulations. Though specific regulations are not provided for this exam, general IT best practices and compliance frameworks emphasize such processes. This approach increases the likelihood of unforeseen issues, service disruptions, and security vulnerabilities, potentially leading to non-compliance with service-level agreements, SLAs, and data protection requirements. Relying solely on anecdotal evidence or the opinions of a few team members is also a failure. This approach lacks the rigor required for a professional assessment and can lead to biased conclusions. It bypasses the systematic data collection and analysis necessary to identify all potential impacts, thereby increasing the risk of negative consequences and potential non-compliance with operational standards. Focusing exclusively on the immediate technical benefits without considering broader operational, security, or cost implications is another failure. This narrow perspective neglects the holistic nature of VCF management and can lead to unintended consequences in other areas, such as increased operational overhead, security gaps, or unexpected cost escalations. This oversight can result in non-compliance with broader organizational policies and potentially with regulatory requirements related to resource management and security. Professional reasoning. Professionals managing VCF environments should adopt a structured approach to change management. This involves 1. Initiating a formal change request process. 2. Conducting a thorough impact assessment that considers technical, operational, security, and business aspects. 3. Engaging relevant stakeholders for input and validation. 4. Developing a detailed implementation plan including rollback procedures. 5. Executing the change during a scheduled maintenance window. 6. Performing post-implementation verification and monitoring. This framework ensures that changes are managed effectively, risks are minimized, and the VCF environment remains stable, secure, and compliant. Question 4. Cost-benefit analysis shows that deploying VMware Cloud Foundation 5.2 with a simplified network configuration, prioritizing immediate cost reduction in network hardware, offers significant upfront savings. However, this simplified configuration may limit future scalability and introduce complexities in segmenting sensitive workloads according to established security policies. What is the most professionally responsible approach to proceed? Option A. Conduct a detailed impact assessment that evaluates the long-term operational, security, and scalability implications of the simplified network configuration, comparing it against alternative VCF network designs that may have higher initial costs but offer better alignment with security policies and future growth. Option B. Proceed with the simplified network configuration immediately to realize the cost savings and address any scalability or security issues as they arise in the future. Option C. Implement the simplified network configuration, but postpone the implementation of advanced network segmentation features until a later phase, assuming they will be less critical for initial deployment. Option D. Request a revised cost-benefit analysis that excludes any potential future costs associated with network upgrades or security remediation, focusing solely on the immediate hardware savings. The correct answer is A. Conduct a detailed impact assessment that evaluates the long-term operational, security, and scalability implications of the simplified network configuration, comparing it against alternative VCF network designs that may have higher initial costs but offer better alignment with security policies and future growth. Explanation. The scenario presents a common challenge in IT infrastructure management, balancing the immediate benefits of a new technology with its potential long-term impacts on operational efficiency and security. The professional challenge lies in moving beyond a purely cost-driven decision to a holistic impact assessment that considers all facets of the VMware Cloud Foundation (VCF) deployment. This requires foresight and an understanding of how seemingly minor technical choices can cascade into significant operational or compliance issues. The correct approach represents best professional practice because it prioritizes a comprehensive understanding of the VCF ecosystem and its integration points. By conducting a thorough impact assessment that includes operational, security, and performance considerations, the administrator ensures that the chosen deployment strategy aligns with established VCF best practices and any relevant internal or external regulatory frameworks. This proactive stance minimizes the risk of unforeseen issues, reduces the likelihood of costly rework, and upholds the integrity and security of the cloud environment. This aligns with the principles of responsible IT governance, which emphasize due diligence and risk mitigation. An incorrect approach that focuses solely on the initial cost savings, without considering the operational overhead of managing a less integrated or less secure configuration, would be professionally unacceptable. This failure represents a disregard for long-term operational stability and potentially introduces security vulnerabilities that could lead to data breaches or non-compliance with data protection regulations. Another incorrect approach that overlooks the performance implications of specific configuration choices could lead to degraded application performance, impacting business operations and user satisfaction, which is a failure in delivering a reliable service. A third incorrect approach that neglects to assess the compatibility with existing security policies and tools could result in a VCF environment that is not adequately protected, creating a significant compliance and security risk. Professionals should employ a decision-making framework that begins with clearly defining the business objectives for the VCF deployment. This should be followed by a thorough impact assessment that covers technical feasibility, operational requirements, security posture, performance expectations, and compliance obligations. Only after this comprehensive evaluation should cost-benefit analysis be applied to evaluate different deployment options against the established criteria. This systematic approach ensures that decisions are not only financially sound, but also strategically aligned with the organization's overall goals and risk appetite. Question 5. Assessment of the impact of integrating a new third-party management tool into an existing VMware Cloud Foundation 5. 2. Environment, focusing on its potential to introduce security vulnerabilities or operational disruptions, requires a systematic evaluation. Which of the following approaches best ensures the integrity and security of the VCF deployment? Option A. Prioritizing the immediate deployment of the tool to leverage its new features, with a commitment to perform a post-deployment review of its security and operational impact. Option B. Performing a limited assessment focused solely on the tool's core functionality and its immediate integration points, without extensive review of its broader security implications or operational dependencies. Option C. Proceeding with the integration based on the vendor's assurance of seamless compatibility and security, with a plan to address any issues that arise after deployment. Option D. Conducting a detailed security and operational impact analysis, including compatibility testing with current VCF configurations, review of the tool's access controls and data handling practices, and validation against internal security policies and relevant compliance frameworks. The correct answer is D. Conducting a detailed security and operational impact analysis, including compatibility testing with current VCF configurations, review of the tool's access controls and data handling practices, and validation against internal security policies and relevant compliance frameworks. Explanation. Scenario analysis. This scenario presents a common challenge in cloud administration, balancing the need for rapid deployment and feature adoption with the imperative to maintain a secure and compliant environment. The pressure to deliver new services quickly can lead to shortcuts in the impact assessment process, potentially introducing vulnerabilities or non-compliance with internal policies or external regulations. The challenge lies in effectively communicating the risks associated with expedited deployments and ensuring that the necessary due diligence is performed without unduly hindering innovation. Correct approach analysis. The correct approach involves a structured and comprehensive impact assessment that considers all relevant aspects of the proposed change. This includes evaluating potential security implications, such as data exposure or unauthorized access, and assessing the impact on existing services and infrastructure. Crucially, it requires understanding how the change aligns with VMware Cloud Foundation's architectural principles and operational best practices, as well as any applicable regulatory requirements. A thorough assessment ensures that risks are identified, understood, and mitigated before implementation, thereby upholding the integrity and security of the cloud environment. This aligns with the principle of security by design and responsible IT governance, which are implicitly expected in professional cloud administration. Incorrect approach is analysis. One incorrect approach is to proceed with the deployment based solely on the vendor's claims of compatibility and security. This fails to account for the specific configuration and operational context of the organization's VMware Cloud Foundation environment. It bypasses the critical step of verifying that the new feature integrates seamlessly and securely within the existing security posture and operational workflows, potentially leading to unforeseen conflicts or vulnerabilities. This approach demonstrates a lack of due diligence and an over-reliance on external assurances, which is professionally unsound. Another incorrect approach is to prioritize speed of deployment over a thorough risk evaluation, assuming that any potential issues can be addressed post-implementation. This is a reactive and inherently risky strategy. It ignores the potential for significant disruption, data breaches, or compliance violations that could occur during the interim period. The principle of proactive risk management is violated, and the organization is exposed to unnecessary threats. This approach can lead to costly remediation efforts and reputational damage. A third incorrect approach is to conduct a superficial assessment that only considers the immediate functional impact of the new feature, neglecting broader security, compliance, and operational considerations. This narrow focus can lead to overlooking critical dependencies or downstream effects that could compromise the overall stability and security of the VMware Cloud Foundation. It demonstrates a failure to adopt a holistic view of the IT ecosystem and its interconnectedness, which is a hallmark of professional IT management. Professional reasoning. Professionals should adopt a risk-based approach to impact assessment. This involves identifying potential threats and vulnerabilities, evaluating their likelihood and impact, and determining appropriate mitigation strategies. The process should be iterative and involve collaboration with relevant stakeholders, including security teams, operations, and compliance officers. When faced with pressure to expedite, professionals must clearly articulate the risks associated with bypassing or abbreviating the assessment process, and advocate for adherence to established procedures. The decision-making framework should prioritize the long-term stability, security, and compliance of the environment over short-term gains. Question 6. Comparative studies suggest that when planning a vSphere version upgrade within a VMware Cloud Foundation 5.2 environment, the most critical initial step to ensure a stable and functional SDDC is to Option A. Rely on community forums and anecdotal evidence from other administrators for guidance on the upgrade process. Option B. Proceed with the vSphere upgrade based on general vSphere upgrade best practices, assuming compatibility with other VCF components. Option C. Immediately initiate the vSphere upgrade to leverage the latest features and security patches as soon as they are available. Option D. Consult the VMware Cloud Foundation release notes and upgrade guide for the target version. Verify component compatibility using VMware's product interoperability matrices, and perform a pre-upgrade health check using SDDC Manager. The correct answer is D. Consult the VMware Cloud Foundation release notes and upgrade guide for the target version. Verify component compatibility using VMware's product interoperability matrices, and perform a pre-upgrade health check using SDDC Manager. Explanation. Scenario analysis. This scenario presents a professional challenge in a VMware Cloud Foundation (VCF) 5.2 environment where a planned infrastructure upgrade, specifically a vSphere version update, is being considered. The core challenge lies in accurately assessing the potential impact of this upgrade on the existing VCF deployment, which includes tightly integrated components like NSXT, vSAN, and SDDC Manager. A failure to conduct a thorough impact assessment could lead to service disruptions, data loss, performance degradation, or even a complete VCF stack failure, all of which have significant operational and potentially financial consequences. The complexity arises from the interdependencies within VCF. An update to one component can have cascading effects on others. Professional judgment is required to balance the benefits of the upgrade e.g., new features, security patches, performance improvements, against the risks of disruption. Correct approach analysis. The correct approach involves a systematic and comprehensive impact assessment that leverages VMware's official documentation and best practices for VCF upgrades. This includes consulting the VMware product interoperability matrices to verify compatibility between the target vSphere version and all other VCF components, NSXT, vSAN, SDDC Manager, etc. Furthermore, it necessitates reviewing the VMware Cloud Foundation release notes and upgrade guide for the specific VCF version being targeted, as these documents detail known issues, prerequisites, and the recommended upgrade path. Critical step is to perform a pre-upgrade health check of the VCF environment using SDDC Manager to identify any existing issues that could be exacerbated by the upgrade. Finally, developing a detailed rollback plan is paramount. This methodical approach ensures that all potential risks are identified, mitigated, and that a contingency plan is in place, aligning with the professional responsibility to maintain service availability and data integrity. Incorrect approach is analysis. An incorrect approach would be to proceed with the vSphere upgrade based solely on general knowledge of vSphere updates, without considering the specific VCF integration. This is professionally unacceptable because VCF is a curated stack where components are validated to work together at specific versions. Upgrading vSphere in isolation, without verifying its compatibility with the VCF version and its integrated components, NSXT, vSAN, can lead to severe interoperability issues, rendering the VCF environment unstable or inoperable. Another incorrect approach is to rely on anecdotal evidence or community forums for upgrade guidance without cross-referencing official VMware documentation. While community insights can be helpful, they do not replace the authoritative guidance provided by VMware. Relying on unverified information can lead to the adoption of unsupported configurations or the overlooking of critical prerequisites or known issues documented by the vendor, thereby increasing the risk of a failed upgrade and subsequent service disruption. A third incorrect approach is to skip the pre-upgrade health check and rollback plan development. The pre-upgrade health check is designed to identify potential blockers or issues that could cause the upgrade to fail or lead to instability. Omitting this step is a direct failure to proactively identify and address risks. Similarly, neglecting to create a rollback plan is a critical oversight. In the event of an unforeseen issue during or after the upgrade, a well-defined rollback procedure is essential for quickly restoring the environment to a stable state, minimizing downtime and data loss. This lack of preparedness demonstrates a failure to adhere to standard IT operational best practices for change management. Professional reasoning. Professionals tasked with infrastructure upgrades, especially within complex integrated platforms like VMware Cloud Foundation, must adopt a risk-based, documentation-driven decision-making process. The framework involves 1. Understanding the objective. Clearly define the purpose and expected benefits of the upgrade. 2. Information gathering. Prioritize official vendor documentation, release notes, upgrade guides, compatibility matrices as the primary source of truth. 3. Risk identification. Systematically identify potential risks associated with the upgrade, considering component interdependencies and known issues. 4. Mitigation planning. Develop strategies to mitigate identified risks, including pre-upgrade checks, configuration adjustments, and resource allocation. 5. Contingency planning. Create a detailed rollback plan to revert to the previous stable state if the upgrade fails or causes unacceptable issues. 6. Execution and monitoring. Perform the upgrade in a controlled manner, with continuous monitoring for anomalies. 7. Post-upgrade validation. Thoroughly test all critical functionalities after the upgrade. This structured approach ensures that decisions are informed, risks are managed, and the integrity and availability of the VCF environment are maintained. Question 7. Compliance review shows that a new network segmentation policy is being implemented across several vSphere clusters within VMware Cloud Foundation. The team responsible for this change has documented the technical steps, but has not formally assessed the potential impact on application availability, data access controls, or existing compliance obligations. What is the most appropriate next step to ensure adherence to best practices and regulatory expectations? Option A. Immediately halt all implementation activities and conduct a full, in-depth impact assessment for every aspect of the proposed policy, regardless of initial perceived risk. Option B. Rely on automated network scanning tools to identify any immediate connectivity issues post-implementation, considering this sufficient for impact assessment. Option C. Proceed with the implementation as planned, assuming that network changes are inherently low risk and do not require extensive impact assessment. Option D. Initiate a phased impact assessment, starting with a preliminary review to categorize the change's potential risk and determine the required depth of subsequent analysis. The correct answer is D. Initiate a phased impact assessment, starting with a preliminary review to categorize the change's potential risk and determine the required depth of subsequent analysis. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments where the rapid pace of deployment can outstrip formal impact assessment processes. The professional challenge lies in balancing the need for agility and innovation with the imperative to understand and mitigate potential risks before they manifest. The pressure to deliver new services quickly can lead to shortcuts in due diligence, creating a significant risk of non-compliance and operational disruption. Careful judgment is required to identify the appropriate level of assessment for different types of changes, ensuring that critical systems and data are protected without unduly hindering progress. Correct approach analysis. The correct approach involves a phased impact assessment that scales with the complexity and potential risk of the proposed change. This aligns with best practices for IT governance and risk management, which are implicitly supported by regulatory frameworks emphasizing due diligence and risk mitigation. By initiating a preliminary assessment to categorize the change and its potential impact on critical business functions, data integrity, security, and compliance, administrators can determine the necessary depth of subsequent analysis. This ensures that resources are allocated efficiently, focusing intensive assessment on high-risk changes while allowing for streamlined processes for low-risk modifications. This proactive, risk-based methodology is fundamental to maintaining a secure and compliant VMware Cloud Foundation environment. Incorrect approach is analysis. One incorrect approach is to bypass any formal impact assessment for changes deemed minor or routine by the implementing team. This is a significant regulatory and ethical failure because it relies on subjective judgment rather than objective criteria. What appears minor to one team could have cascading, unforeseen impacts on other systems or critical business processes, potentially leading to data breaches, service disruption, or compliance violations. Another incorrect approach is to conduct a full, detailed impact assessment for every single change, regardless of its scope or potential risk. This is inefficient and can stifle innovation, but more importantly, it can lead to assessment fatigue, where the thoroughness of assessments diminishes over time due to sheer volume, ultimately undermining the effectiveness of the process. It also represents a failure to apply risk-based principles, which are often a cornerstone of regulatory expectations for efficient resource allocation in IT operations. A third incorrect approach is to rely solely on automated tools without human oversight for impact assessment. While automation is valuable, it may not capture nuanced dependencies, business context, or emerging threats that a human analyst would recognize. This can lead to missed risks and a false sense of security, which is a failure in due diligence and professional responsibility. Professional reasoning. Professionals should adopt a risk-based approach to impact assessment. This involves establishing clear criteria for categorizing changes based on their potential impact on security, availability, performance, and compliance. For each category, a defined assessment process should be followed, ranging from a quick checklist for low-risk changes to a comprehensive review for high-risk modifications. This framework ensures that all changes are evaluated, but with an appropriate level of rigor. Regular review and refinement of the impact assessment process, based on lessons learned and evolving threat landscapes, are also crucial for maintaining effectiveness and compliance. Question 8. To address the challenge of upgrading a VMware Cloud Foundation 5.2 environment to incorporate new security patches and performance enhancements, which of the following approaches best ensures data integrity and operational continuity while adhering to best practices for cloud infrastructure management? Option A. Execute a phased upgrade of individual VCF components, starting with management domain components and progressing to workload domains, with thorough validation and testing at each stage, including pre- and post-upgrade data integrity checks. Option B. Rely exclusively on automated upgrade scripts provided by third-party vendors without performing any internal validation or risk assessment of the upgrade process. Option C. Initiate a simultaneous, in-place upgrade of all VCF components across the entire environment to minimize downtime and accelerate the deployment of new features. Option D. Temporarily disable all security monitoring and logging services during the upgrade process to reduce overhead and expedite the patching of critical vulnerabilities. The correct answer is A. Execute a phased upgrade of individual VCF components, starting with management domain components and progressing to workload domains, with thorough validation and testing at each stage, including pre- and post-upgrade data integrity checks. Explanation. The scenario presents a common challenge in cloud environments, ensuring data integrity and compliance during a significant infrastructure upgrade. The professional challenge lies in balancing the need for rapid deployment of new features and improved performance with the absolute requirement to maintain data confidentiality, integrity, and availability, as mandated by VMware's own best practices, and potentially by broader industry compliance standards that VMware Cloud Foundation, VCF, is designed to support. The critical judgment required stems from the potential for data corruption or unauthorized access if the upgrade process is not meticulously planned and executed with security and compliance as paramount concerns. The correct approach represents best professional practice because it prioritizes a phased, controlled, and validated upgrade process. This aligns with the principle of least privilege and defense in depth, ensuring that each stage of the upgrade is tested and verified before proceeding. Specifically, it involves leveraging VCF's built-in lifecycle management capabilities, which are designed to orchestrate complex upgrades in a predictable and safe manner. This methodology minimizes the risk of introducing vulnerabilities or data loss by allowing for rollback points and thorough testing at each stage. Adherence to VMware's documented upgrade procedures and best practices is not merely a technical recommendation, but a professional obligation to ensure the stability and security of the deployed cloud infrastructure. An incorrect approach that involves a direct, in-place upgrade of all components simultaneously without prior validation or staged rollout would be professionally unacceptable. It bypasses critical testing phases and significantly increases the risk of cascading failures, data corruption, or security breaches. Such an action would violate the professional duty to exercise due care and diligence in managing critical infrastructure. Another incorrect approach, such as disabling security controls to expedite the upgrade, represents a severe ethical and professional failure. Security is a foundational requirement, and compromising it, even temporarily, for speed is a direct contravention of professional responsibility and could lead to significant data breaches and reputational damage. A third incorrect approach, relying solely on vendor support without internal validation or understanding of the upgrade process, demonstrates a lack of ownership and due diligence. While vendor support is valuable, the administrator remains ultimately responsible for the integrity and security of the deployed environment. The professional decision-making process should involve a thorough understanding of the VCF upgrade documentation, risk assessment of each upgrade step, and the implementation of a robust testing and validation strategy. Professionals must prioritize a systematic and controlled approach, utilizing the tools and features provided by VCF for lifecycle management. This includes understanding rollback procedures and having contingency plans in place. The decision to proceed with any upgrade should be based on a comprehensive evaluation of potential risks and the effectiveness of mitigation strategies, always prioritizing data integrity and security. Question 9. Process analysis reveals that a critical virtual machine within a VMware Cloud Foundation 5.2 environment is no longer required for operational purposes. The virtual machine has been running for several years and has accumulated significant data, including application logs and user-generated content. Before proceeding with its removal, what is the most critical step to ensure data integrity and compliance? Option A. Inform the application owner that the virtual machine will be decommissioned within the next 24 hours. Option B. Immediately delete the virtual machine from vCenter to free up resources and reclaim storage space. Option C. Verify that all associated data, including any snapshots, backups, and persistent storage, has been handled according to data retention policies or securely archived, and then proceed with the documented VM decommissioning process. Option D. Unmount the data stores associated with the virtual machine to prevent further access. The correct answer is C. Verify that all associated data, including any snapshots, backups, and persistent storage, has been handled according to data retention policies or securely archived, and then proceed with the documented VM decommissioning process. Explanation. Scenario analysis. This scenario presents a common challenge in cloud environments, managing the lifecycle of virtual machines, VM, and their associated data, particularly when dealing with sensitive information. The professional challenge lies in balancing operational efficiency, data integrity, and compliance with VMware Cloud Foundation, VCF 5.2 best practices and potential regulatory requirements. Though none are explicitly stated for this exam, the principles of data handling and security are paramount. The need to ensure that data is not inadvertently lost or exposed during decommissioning is critical. The complexity arises from the interconnectedness of VCF components and the potential for residual data on storage. Correct approach analysis. The correct approach involves a systematic and documented process that prioritizes data protection and auditability. This aligns with VCF 5.2's emphasis on robust lifecycle management and operational best practices, specifically ensuring that all data associated with the VM, including any snapshots, backups, or persistent storage, is securely handled before the VM is removed from vCenter and the underlying storage is released, is paramount. This often involves verifying that data retention policies have been met or that data has been migrated to an archival location if required. The process should also include updating inventory and configuration management databases to reflect the VM's removal, preventing orphaned resources and potential security risks. This methodical approach minimizes the risk of data loss and ensures compliance with internal policies and industry standards for data handling. Incorrect approach is analysis. An incorrect approach would be to immediately delete the VM from vCenter without verifying the status of its associated data. This could lead to the accidental deletion of critical data that is still required for compliance, auditing, or business continuity purposes, violating principles of data integrity and responsible resource management. Another incorrect approach would be to simply unmount the VM's data stores without properly decommissioning the VM and its associated data. This leaves the data in an unmanaged state, posing a security risk and potentially consuming storage resources unnecessarily. Furthermore, failing to document the decommissioning process or update relevant systems would hinder auditability and create an incomplete operational picture, which is a failure in professional practice and could lead to future operational issues. Professional reasoning. Professionals should adopt a risk-based approach to VM decommissioning. This involves a pre-decommissioning checklist that includes verifying data retention requirements, ensuring backups are complete and accessible, and confirming that no critical dependencies exist. The process should be clearly defined in standard operating procedures, SOP, and followed consistently. Regular training on VCF lifecycle management and data handling best practices is essential. When in doubt about data status or retention, consult with data owners and compliance officers before proceeding with irreversible actions. Question 10. Stakeholder feedback indicates a critical business application requires immediate deployment within the VMware Cloud Foundation environment. The application's vendor has provided specific network configuration requirements that bypass standard VCF network segmentation policies to achieve perceived performance gains. The VCF administrator is concerned that these bypasses will introduce significant security risks and potential compliance violations. What is the most appropriate course of action? Option A. Implement the requested network bypasses without further investigation, prioritizing the immediate business need over potential, unconfirmed security risks. Option B. Immediately deploy the application as requested by the vendor to meet the critical business need, assuming the vendor's configuration is optimized for their application. Option C. Refuse the deployment outright, citing VCF network segmentation policies as non-negotiable, and inform stakeholders that the application cannot be deployed in its current form. Option D. Conduct a thorough risk assessment of the proposed network bypasses, identify potential security vulnerabilities and compliance implications, and propose compensating controls that meet both the application's performance needs and VCF security best practices. The correct answer is D. Conduct a thorough risk assessment of the proposed network bypasses, identify potential security vulnerabilities and compliance implications, and propose compensating controls that meet both the application's performance needs and VCF security best practices. Explanation. Scenario analysis. This scenario presents a common challenge in cloud administration, balancing the need for rapid deployment and feature adoption with the imperative of maintaining a secure and compliant infrastructure. Stakeholders, driven by business needs, may prioritize speed over adherence to established security protocols, creating a tension that requires careful navigation. The administrator must act as a gatekeeper, ensuring that new services integrate seamlessly and securely without introducing vulnerabilities or violating VMware Cloud Foundation (VCF) best practices and underlying regulatory frameworks that VCF is designed to support. The challenge lies in effectively communicating the risks associated with bypassing security controls and finding solutions that meet both business and compliance requirements. Correct approach analysis. The correct approach involves a thorough risk assessment and the implementation of compensating controls. This aligns with the principle of least privilege and defense in depth, fundamental tenets of secure cloud architecture. By engaging with the stakeholders to understand the business drivers, the administrator can then identify specific security requirements that are being bypassed. Subsequently, proposing and implementing alternative security measures that achieve a similar level of protection, even if not the exact same control, demonstrates a proactive and responsible approach. This demonstrates adherence to the VCF security model, which emphasizes a layered security strategy. The focus is on achieving the desired security outcome, not just rigidly adhering to a single, potentially inflexible, control. This approach ensures that the business objectives are met without compromising the integrity and security posture of the VCF environment, thereby upholding the implicit regulatory compliance that VCF is built to facilitate. Incorrect approach is analysis. Allowing the deployment without any security review or implementing alternative controls is a direct violation of security best practices and the principles of secure cloud deployment. This creates a significant security gap, potentially exposing the environment to unauthorized access, data breaches, or service disruptions. From a regulatory perspective, this could lead to non-compliance with data protection regulations and industry-specific security standards that VCF is designed to help organizations meet. Implementing the requested feature without understanding the underlying security implications or the specific VCF security configurations is also problematic. This approach is reactive and lacks a strategic understanding of how the change impacts the overall security posture. It risks introducing misconfigurations or vulnerabilities that are difficult to detect and remediate later, potentially leading to compliance issues. Ignoring the stakeholder request entirely without providing a reasoned explanation or alternative solutions is unprofessional and detrimental to the IT-business relationship. While security is paramount, a complete refusal without engagement can lead to frustration and a perception of IT as an impediment to business progress. This can indirectly lead to stakeholders seeking shadow IT solutions, which are inherently less secure and unmanaged, thus creating greater compliance and security risks. Professional reasoning. Professionals should adopt a risk-based approach. This involves understanding the business need, identifying the associated security risks, evaluating the impact of those risks, and then determining appropriate mitigation strategies. This process should be collaborative, involving communication with stakeholders to explain the rationale behind security decisions. When a direct implementation of a requested feature poses a security risk, the professional should 1. Understand the business objective. 2. Identify the specific security controls that would be bypassed. 3. Assess the potential impact of bypassing these controls. 4. Propose and implement compensating controls that achieve a similar security outcome. 5. Document the decision-making process and the implemented controls. This structured approach ensures that security and compliance are integrated into the operational workflow, rather than being an afterthought. Question 11. Operational review demonstrates that a development team requires immediate access to a specific management network segment within the VMware Cloud Foundation environment to troubleshoot a critical application issue. The standard change control process for network access requests typically involves multiple approval layers and a lead time of 48 hours. The development team lead has requested an expedited, direct network configuration change to resolve the issue urgently. What is the most appropriate course of action for the VMware Cloud Foundation administrator? Option A. Grant the requested network configuration change without any documentation or retrospective process to ensure the critical application issue is resolved as quickly as possible. Option B. Escalate the request to the security operations team for an immediate risk assessment and temporary access approval, outlining the specific network segment and duration required, while simultaneously initiating the standard change control process. Option C. Deny the request due to the urgency and instruct the development team to follow the standard change control process, emphasizing the importance of security and compliance. Option D. Implement the requested network configuration change directly, documenting the action and the reason for expedited processing, and then initiate the standard change control process retrospectively. The correct answer is D. Implement the requested network configuration change directly, documenting the action and the reason for expedited processing, and then initiate the standard change control process retrospectively. Explanation. This scenario presents a common challenge in cloud administration, balancing the need for rapid deployment and resource provisioning with the imperative of maintaining robust security and compliance postures. The professional challenge lies in identifying and mitigating potential security risks introduced by unauthorized or improperly configured network access, which can lead to data breaches, service disruptions, and regulatory noncompliance. The correct approach prioritizes a thorough, documented, and automated process for network access control. This aligns with best practices for secure cloud operations and the principles of least privilege. By leveraging VMware Cloud Foundation's built-in security features and adhering to defined security policies, Administrators ensure that only authorized entities can access specific network segments and resources. This proactive stance minimizes the attack surface and maintains the integrity of the cloud environment, directly supporting the compliance requirements inherent in managing sensitive data and critical infrastructure. An incorrect approach that bypasses established change control and security validation processes introduces significant risk. This failure to adhere to documented security policies and procedures constitutes a direct violation of operational security best practices. It creates an unmonitored and unmanaged entry point, which is a prime target for malicious actors. Such an action would likely violate internal security mandates and could lead to non-compliance with industry-specific regulations or data protection laws, depending on the nature of the data hosted within the VCF environment. Another incorrect approach that relies on ad hoc, manual configuration without proper validation is equally problematic. While seemingly expedient, it lacks the auditability and repeatability required for a secure and compliant environment. Manual configurations are prone to human error, and without a formal review and approval process, misconfigurations can persist undetected, leading to security vulnerabilities. This approach fails to establish a clear audit trail, making it difficult to demonstrate compliance during an audit or incident investigation. The professional reasoning process for such situations should involve a clear understanding of the VCF security model and the organization's security policies. When faced with a request for network access, administrators must 1. Verify the legitimacy and necessity of the request against defined business requirements. 2. Assess the potential security implications of granting the requested access. 3. Ensure the request follows the established change management and approval workflow. 4. Implement the access control using VCF's native tools and security constructs, adhering to the principle of least privilege. 5. Document the change and verify its successful implementation and adherence to security policies. This systematic approach ensures that security and compliance are integrated into operational workflows, rather than being an afterthought. Question 12. Consider a scenario where a critical security patch for VMware Cloud Foundation 5.2 has been released, addressing a zero-day vulnerability. The patch requires a reboot of several core management components. The VCF environment is currently supporting several critical business applications with no scheduled maintenance windows for the next 72 hours. The administrator has access to the patch and the release notes, which detail the required steps and potential risks. What is the most professional course of action? Option A. Delay the application of the patch indefinitely until a scheduled maintenance window becomes available in the next quarter, relying on existing security measures to mitigate the zero-day vulnerability in the interim. Option B. Initiate the patch deployment process after thoroughly reviewing the release notes, assessing the potential impact on ongoing operations, developing a detailed rollback plan, and communicating the proposed deployment window to relevant stakeholders for approval. Option C. Apply the patch to a non-production VCF environment first to test its functionality and impact, and then proceed with the production deployment without further stakeholder consultation, assuming the test results are positive. Option D. Immediately deploy the patch to the management components during a period of low activity, accepting the risk of potential disruption to critical applications, and prepare for immediate rollback if issues arise. Correct answer is D. Immediately deploy the patch to the management components during a period of low activity, accepting the risk of potential disruption to critical applications, and prepare for immediate rollback if issues arise. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for a critical infrastructure update with the potential for disruption and the adherence to established operational procedures. The administrator must make a judgment call that prioritizes system stability and data integrity, while also acknowledging the urgency of the security patch. Careful consideration of the potential impact on ongoing operations and the availability of rollback mechanisms is paramount. The correct approach represents best professional practice because it follows a structured, risk-mitigated process for implementing critical changes. By first assessing the impact, planning the deployment, and ensuring rollback capabilities, the administrator minimizes the risk of unforeseen consequences. This aligns with the principles of responsible IT operations, emphasizing proactive planning and contingency management, which are implicitly supported by the operational guidelines within VMware Cloud Foundation. The focus is on controlled change management to maintain service availability and data integrity. An incorrect approach that bypasses the change control process and deploys the patch immediately without proper assessment or planning would be professionally unacceptable. This failure represents a direct violation of established operational best practices and could lead to significant downtime, data corruption, or security vulnerabilities if the patch introduces unexpected issues. Such an action demonstrates a disregard for the potential impact on the business and its users, prioritizing speed over safety and control. Another incorrect approach, such as delaying the patch indefinitely due to fear of disruption, would also be professionally unsound. While caution is necessary, a critical security patch addresses known vulnerabilities. Failing to implement it in a timely manner, even with a plan to address it later, exposes the environment to known risks, which is a failure of due diligence and security responsibility. This approach neglects the proactive security posture required for maintaining a secure and compliant environment. A third incorrect approach might involve attempting to apply the patch without adequate testing in a non-production environment. This bypasses a crucial step in ensuring the patch's compatibility and stability within the specific VCF deployment. The regulatory and ethical failure here lies in the potential for introducing instability or incompatibility into the production environment, leading to service degradation or outages, which is a breach of professional duty to maintain reliable systems. The professional reasoning process for similar situations should involve a clear understanding of the change management lifecycle. This includes assessing the risk and impact of the proposed change, developing a detailed implementation plan, identifying and preparing rollback procedures, communicating the plan to stakeholders, executing the change in a controlled manner, and verifying the successful implementation. Prioritizing security updates while adhering to these structured processes ensures that critical vulnerabilities are addressed without compromising the stability and availability of the VMware Cloud Foundation environment. Question 13. The investigation demonstrates that a VMware Cloud Foundation administrator, while troubleshooting a performance issue within a customer's multi-tenant environment, accessed raw system logs that contained sensitive customer configuration details and potentially PII. The administrator then shared these raw logs with a third-party vendor for analysis without explicit customer consent or anonymization. This action was taken to expedite the resolution of the performance issue. Which of the following approaches best aligns with regulatory compliance and professional best practices for data handling in this scenario? Option A. Collecting and retaining all system logs indefinitely for potential future troubleshooting needs, regardless of their content, is a standard operational procedure. Option B. Implementing robust data anonymization or pseudonymization techniques on the logs before sharing them with third-party vendors, and ensuring access is strictly limited to necessary data elements for troubleshooting, is the most compliant approach. Option C. Relying on the third-party vendor's internal security protocols to protect the shared raw logs, assuming they are a reputable company, is sufficient. Option D. Accessing and sharing raw logs with third-party vendors is acceptable when it expedites issue resolution, as the primary goal is to restore service. The correct answer is D. Accessing and sharing raw logs with third-party vendors is acceptable when it expedites issue resolution, as the primary goal is to restore service. Explanation. Scenario analysis. This scenario presents a professional challenge related to data privacy and security within a VMware Cloud Foundation (VCF) environment. The core difficulty lies in balancing the operational need for system monitoring and troubleshooting with the regulatory obligation to protect sensitive customer data. Misinterpreting or misapplying data handling policies can lead to significant compliance breaches, reputational damage, and potential legal repercussions. The administrator must exercise careful judgment to ensure that any data accessed or processed for troubleshooting purposes is done so in a manner that strictly adheres to the specified regulatory framework. Correct approach analysis. The correct approach involves a thorough understanding and strict adherence to the data handling policies and procedures mandated by the relevant regulatory framework. This includes identifying and classifying sensitive data, implementing access controls, anonymizing or pseudonymizing data where feasible, and ensuring that any data accessed is only for legitimate troubleshooting purposes and is not retained or shared inappropriately. This approach represents best professional practice because it directly aligns with the principles of data minimization, purpose limitation, and security by design, which are fundamental to most data privacy regulations. It demonstrates a commitment to protecting customer trust and avoiding regulatory noncompliance. Incorrect approaches analysis. Accessing raw log files containing sensitive customer information without proper authorization or anonymization is a direct violation of data privacy principles. It exposes the organization to risks of data breaches and noncompliance with regulations that mandate the protection of personally identifiable information, PI, or other sensitive data. This approach fails to implement necessary safeguards and demonstrates a disregard for data minimization. Sharing raw log files with external support personnel without a clear need to know, and without ensuring the data is appropriately protected or anonymized, constitutes a significant security and privacy failure. This can lead to unauthorized disclosure of sensitive information, contravening regulations that require organizations to maintain confidentiality and implement appropriate security measures for data in transit and at rest. Implementing broad, indiscriminate data collection policies across the entire VCF environment without specific justification or granular controls increases the risk of inadvertently collecting and storing excessive sensitive data. This approach violates the principle of data minimization and can lead to compliance issues if the collected data is not adequately protected or if its collection cannot be justified by a legitimate business or operational need. Professional reasoning. Professionals in this field should adopt a risk-based approach to data handling. This involves understanding the types of data present in the VCF environment, identifying potential risks associated with its access and processing, and implementing controls commensurate with those risks. A key decision-making framework involves the privacy by design and security by design principles, where data protection considerations are integrated into the system's architecture and operational processes from the outset. When troubleshooting, always ask, is this data necessary for the task? Is this data sensitive? How can I minimize exposure of sensitive data? And am I authorized to access and process this data in this manner? Consulting internal compliance officers or legal counsel, when in doubt, is also a critical step in ensuring adherence to regulatory requirements. Question 14. Upon reviewing the security posture of a newly deployed VMware Cloud Foundation 5.2 environment, an administrator identifies that while the core VCF services are operational, there is a desire to implement advanced intrusion detection capabilities. Considering the integrated nature of VCF and its focus on a unified management plane, which of the following approaches best aligns with VCF 5.2's design principles and ensures a secure, manageable, and supported deployment? Option A. Manually install and configure a third-party intrusion detection system, IDs, directly onto the management domain hosts, bypassing the VCF integrated security services. Option B. Immediately deploy the latest available IDS software from any vendor, assuming newer versions will inherently provide better security, without verifying compatibility or integration with VCF 5.2. Option C. Explore and deploy security solutions that are explicitly listed as compatible and integrated within the VMware Cloud Foundation 5.2 Bill of Materials, BOM, and documentation, ensuring they leverage VCF's native management and lifecycle capabilities. Option D. Defer the implementation of advanced IDS capabilities until a future major upgrade of VCF, prioritizing only the core functionality for the current deployment. The correct answer is A. Manually install and configure a third-party intrusion detection system, IDs, directly onto the management domain hosts, bypassing the VCF integrated security services. Explanation. This scenario presents a common challenge in cloud administration, balancing the need for rapid deployment and feature adoption with the imperative of maintaining a secure and compliant infrastructure. The professional challenge lies in understanding the implications of different deployment models for security posture and adherence to VMware's recommended best practices, which are implicitly tied to operational efficiency and supportability within the VCF framework. The correct approach represents best professional practice because it aligns with the fundamental principles of VMware Cloud Foundation's architecture and security design. By leveraging the integrated, pre-validated components, and adhering to the lifecycle management processes, administrators ensure that the deployed environment is consistent, secure, and supported. This proactive stance minimizes the risk of misconfigurations, security vulnerabilities, and operational issues that could arise from manual or ad hoc modifications. It directly supports the goal of a stable and predictable VCF environment, which is crucial for business operations. An incorrect approach that involves manually installing and configuring third-party security solutions outside of the VCF integrated services fails to acknowledge the inherent security design of VCF. This can lead to integration conflicts, bypasses of VCF security controls, and a lack of centralized management and visibility. From a regulatory and ethical standpoint, this approach introduces unmanaged risk, potentially violating compliance mandates that require auditable and controlled security measures. It also undermines the vendor support model, as unsupported configurations can lead to complex troubleshooting and extended downtime. Another incorrect approach, focusing solely on deploying the latest features without considering their integration or impact on the existing VCF baseline, is also professionally unacceptable. This can introduce instability, security vulnerabilities, and compatibility issues. Ethically, it demonstrates a lack of due diligence in ensuring the integrity and security of the production environment. Regulatory frameworks often mandate change control and impact assessments, which are bypassed by such a reactive and uncoordinated deployment strategy. A third incorrect approach, prioritizing cost savings by using unsupported or deprecated components, is professionally unsound and ethically questionable. This not only jeopardizes the security and stability of the environment, but also violates the principle of providing a reliable and secure service. Regulatory compliance is severely compromised when using components that are no longer patched or supported, leaving the organization exposed to known vulnerabilities. The professional decision-making process for similar situations should involve a thorough understanding of the VCF architecture, its integrated services, and the implications of any proposed changes. This includes consulting VMware's official documentation, release notes, and best practices. A risk assessment should be performed for any deviation from the standard VCF deployment model, considering security, operational, and compliance impacts. Change management processes, including thorough testing in non-production environments, are essential before implementing changes in production. Prioritizing a secure, stable, and supported environment is paramount, even if it means a slightly longer deployment time or a more constrained feature set initially. Question 15. Strategic planning requires a careful evaluation of resource allocation and workload placement within a VMware Cloud Foundation 5.2 environment. When designing the initial deployment of the SDDC management domain, which of the following approaches best ensures the stability, security, and scalability of the core VCF infrastructure? Option A. Prioritize the deployment of high-demand production applications within the management domain to demonstrate immediate value and ROI. Option B. Allocate minimal resources to the management domain, assuming that additional resources can be easily added later without impacting existing operations. Option C. Consolidate as many production workloads as possible into the initial management domain to maximize hardware utilization and reduce initial capital expenditure. Option D. Deploy the management domain with dedicated resources sufficient for its core functions and essential management services, followed by a phased introduction of workload domains based on monitoring and projected growth. The correct answer is D. Deploy the management domain with dedicated resources sufficient for its core functions and essential management services, followed by a phased introduction of workload domains based on monitoring and projected growth. Explanation: Strategic planning for VMware Cloud Foundation, VCF 5.2 deployment necessitates a thorough understanding of its core components and their interdependencies, particularly concerning the software-defined data center, SDDC management domain. A common challenge arises when organizations aim to optimize resource utilization and operational efficiency by consolidating multiple workloads within a single VCF instance. This scenario is professionally challenging because an improperly designed management domain can lead to performance bottlenecks, security vulnerabilities, and operational complexity, directly impacting the stability and scalability of the entire VCF environment. Careful judgment is required to balance the desire for consolidation with the inherent requirements of VCF architecture. The correct approach emphasizes a phased deployment strategy that aligns with VCF best practices for the management domain. This involves initially deploying the management domain with sufficient resources to support its critical functions: vCenter Server, NSX Manager, SDDC Manager, and essential management workloads. Subsequent expansion of the management domain, or the introduction of workload domains, should be carefully planned based on resource monitoring and projected growth. This approach represents best professional practice because it adheres to VMware's recommended architecture, ensuring the stability and resilience of the core VCF infrastructure. It also aligns with the principle of least privilege and separation of concerns, which are fundamental to robust IT security and operational management. By starting with a well-provisioned management domain, administrators can effectively monitor performance, troubleshoot issues, and scale resources predictably, minimizing disruption and risk. An incorrect approach would be to aggressively consolidate management and production workloads into the initial management domain to reduce perceived infrastructure costs. This fails to acknowledge the distinct resource demands and criticality of the management domain components. Specifically, it can lead to resource contention, where management services are starved of CPU, memory, or network resources due to the demands of production workloads. This directly violates the principle of operational stability and can result in degraded performance or complete unavailability of critical management functions, impacting the entire SDDC. Furthermore, mixing sensitive management components with less secure production workloads increases the attack surface and complicates security auditing and compliance efforts. Another incorrect approach involves neglecting to allocate sufficient network bandwidth and latency considerations for the management domain. This can lead to slow communication between VCF components, impacting deployment times, updates, and overall responsiveness of the SDDC, creating an unstable and unreliable environment. The professional reasoning process for such a situation should involve a detailed assessment of current and future workload requirements, a deep understanding of VCF architectural principles, and adherence to VMware's official documentation and best practices. Professionals should prioritize stability and security of the management domain, treating it as the foundation of the VCF environment. Decision-making should be guided by a risk-based approach, where potential impacts on critical management functions are thoroughly evaluated before any deployment or consolidation decisions are made. This involves consulting with stakeholders, performing capacity planning, and conducting pilot deployments or simulations where feasible. Question 16. Examination of the data shows that development teams require increased autonomy for provisioning and managing their application environments within VMware Cloud Foundation 5. 2. To accelerate release cycles. The current security posture mandates strict adherence to data protection regulations and requires comprehensive audit trails for all administrative actions, which approach best balances the need for developer agility with the organization's security and compliance obligations. Option A. Grant development team leads broad administrative privileges within the vCenter Server and NSXT Manager to allow them to manage their environments without direct oversight. Option B. Allow development teams to bypass standard change management processes for resource provisioning to expedite deployments, with the understanding that security will be addressed later. Option C. Implement granular role-based access control (RBAC) for specific vSphere and NSXT resources, integrated with the organization's identity provider, and enforce security policies through automated means like NSXT security groups and vSphere DRS affinity rules. Option D. Rely on manual security reviews and periodic audits conducted by the security team to ensure compliance after development teams have provisioned their resources. The correct answer is C. Implement granular role-based access control (RBAC) for specific vSphere and NSXT resources, integrated with the organization's identity provider, and enforce security policies through automated means like NSXT security groups and vSphere DRS affinity rules. Explanation. The scenario presents a common challenge in cloud administration, balancing the need for rapid deployment and resource provisioning with the imperative to maintain robust security and compliance postures. The administrator is tasked with enabling self-service capabilities for development teams, which inherently introduces a degree of autonomy and potential for misconfiguration or unauthorized access. The professional challenge lies in designing and implementing a solution that empowers developers while adhering to the strict security and governance policies mandated by the organization, and by extension, the regulatory framework governing their operations. This requires a deep understanding of VMware Cloud Foundation's capabilities for access control, policy enforcement, and auditing, ensuring that any self-service offering is built upon a foundation of secure defaults and continuous monitoring. The correct approach emphasizes a layered security model, leveraging VMware Cloud Foundation's native features for role-based access control (RBAC) and policy-driven governance, by carefully defining granular permissions for specific vSphere and NSXT resources, and integrating with existing identity management systems. The administrator can ensure that developers only have access to the resources and operations necessary for their tasks. This aligns with the principle of least privilege, a cornerstone of secure system design, and a common requirement in regulatory compliance frameworks that mandate data protection and access control. Furthermore, implementing automated policy enforcement through vSphere Distributed Resource Scheduler (DRS), affinity rules, and NSXT security groups ensures that deployed workloads adhere to organizational security standards from the outset, minimizing the risk of compliance violations. Continuous monitoring and auditing capabilities within VCF provide the necessary visibility to detect and respond to any deviations from policy. An incorrect approach that grants broad administrative privileges to development teams without granular controls represents a significant security and compliance failure. This directly violates the principle of least privilege, exposing the environment to unauthorized access, accidental misconfigurations, and potential data breaches. Such an approach would likely contravene regulations requiring strict access controls and audit trails for sensitive data and critical infrastructure. Another incorrect approach that relies solely on manual oversight and ad hoc security checks is also professionally unacceptable. While well-intentioned, manual processes are prone to human error, scalability issues, and delays in identifying and rectifying security vulnerabilities. This reactive rather than proactive stance fails to meet the proactive security and compliance requirements often stipulated by regulatory bodies, which emphasize continuous monitoring and automated enforcement. A third incorrect approach that bypasses established change management and approval workflows to expedite deployments introduces unacceptable risk. This undermines the organization's governance framework and increases the likelihood of introducing insecure configurations or violating compliance policies. Regulatory frameworks typically mandate documented processes for changes to critical systems to ensure accountability and prevent unauthorized modifications. The professional decision-making process for similar situations should involve a thorough risk assessment, a clear understanding of the organization's security and compliance requirements, and a detailed evaluation of the available tools and features within VMware Cloud Foundation. Prioritizing a security-first mindset, implementing the principle of least privilege, and leveraging automation for policy enforcement and monitoring are critical steps in building a secure and compliant self-service cloud environment. Question 17. Performance analysis shows a consistent increase in application latency for a critical business application hosted on VMware Cloud Foundation 5. 2. The latency spikes correlate with periods of high user activity, but the underlying cause is not immediately apparent from basic resource utilization metrics. Option A. Initiate a migration of the application to a different cloud platform to bypass the perceived performance limitations of the current VCF environment. Option B. Conduct a deep dive analysis of the application's resource consumption patterns within VCF, examining compute, storage I/O, and network traffic patterns specific to the application's VMs and underlying VCF infrastructure components. Option C. Immediately provision additional CPU and memory resources to the virtual machines hosting the application to alleviate potential resource contention. Option D. Focus solely on optimizing the application code itself, assuming that the VCF infrastructure is performing optimally and the issue lies entirely within the application's logic. Correct answer is B. Conduct a deep dive analysis of the application's resource consumption patterns within VCF, examining compute, storage I/O, and network traffic patterns specific to the application's VMs and underlying VCF infrastructure components. Explanation: this scenario presents a common challenge in cloud administration, balancing performance optimization with resource allocation and cost management. The professional challenge lies in interpreting performance metrics accurately and translating them into actionable, compliant, and cost-effective solutions within the VMware Cloud Foundation, VCF 5.2 framework. The requirement to adhere strictly to VCF 5.2 guidelines means that any proposed solution must align with its architectural principles, operational best practices, and any implicit or explicit recommendations for resource management. The correct approach represents best professional practice because it involves a systematic, data-driven investigation that considers the holistic impact of performance issues. By analyzing the specific workload, its resource demands, and potential bottlenecks within the VCF stack, e.g., compute, storage, network, it allows for targeted remediation. This aligns with the VCF 5.2 administrator's responsibility to maintain a stable, performant, and efficient environment. The focus on understanding the root cause before implementing changes is crucial for avoiding unintended consequences and ensuring long-term system health, which is a core tenet of responsible IT operations. An incorrect approach that focuses solely on increasing compute resources without understanding the underlying issue represents a failure in professional due diligence. This could lead to unnecessary expenditure and may not resolve the actual performance bottleneck if it lies elsewhere, such as in storage I/O or network latency. Ethically, this approach could be seen as wasteful and not in the best interest of the organization's resources. Another incorrect approach, such as migrating the workload to a different platform without a thorough VCF native analysis, bypasses the administrator's core responsibilities and expertise within the VCF environment. This could be a premature decision driven by a lack of understanding or a desire for a quick fix, rather than a strategic, informed choice. It fails to leverage the capabilities of VCF and could introduce new complexities or compliance issues. The professional reasoning process should involve 1. Acknowledging the performance anomaly reported. 2. Initiating a detailed investigation using VCF's built-in monitoring and logging tools to identify the specific resource constraints or errors. 3. Correlating performance metrics with workload behavior and VCF infrastructure health. 4. Evaluating potential solutions based on their impact, cost, and alignment with VCF best practices. 5. Implementing the most appropriate solution with careful monitoring of its effectiveness. Question 18. Risk assessment procedures indicate that the introduction of new services and configurations into VMware Cloud Foundation 5.2 environments is a significant vector for potential security vulnerabilities and compliance deviations. Which of the following approaches best mitigates this risk by ensuring consistent security posture and adherence to regulatory requirements throughout the service lifecycle? Option A. Conducting manual security reviews and ad hoc vulnerability scans on newly deployed services after they have been made available to users. Option B. Temporarily disabling or bypassing security controls for new services to expedite their deployment and operational readiness. Option C. Relying solely on the default security configurations provided by VMware Cloud Foundation 5.2 for all new service deployments without specific workload assessment. Option D. Implementing automated security policy enforcement and microsegmentation through VMware NSX, integrated with VCF's declarative configuration model, to define and apply security controls as part of the service deployment workflow. The correct answer is D. Implementing automated security policy enforcement and microsegmentation through VMware NSX, integrated with VCF's declarative configuration model, to define and apply security controls as part of the service deployment workflow. Explanation: scenario analysis. This scenario presents a common challenge in cloud environments where the rapid pace of deployment and the dynamic nature of workloads can outstrip the effectiveness of static security controls. The core difficulty lies in balancing the need for agility and innovation with the imperative to maintain a secure and compliant posture. Specifically, the challenge is to ensure that new services and configurations introduced into VMware Cloud Foundation, VCF 5.2, do not inadvertently create security vulnerabilities or violate established compliance mandates. This requires a proactive and integrated approach to security rather than a reactive one. Correct approach analysis. The correct approach involves leveraging VCF's native capabilities for policy-driven security and compliance. VCF 5.2 integrates with VMware NSX for microsegmentation and security policy enforcement. By defining and automating security policies that are applied consistently across the VCF environment, administrators can ensure that new deployments adhere to predefined security baselines. This includes implementing network segmentation, access controls, and threat detection mechanisms as part of the service deployment lifecycle. This approach aligns with best practices for cloud security and compliance, emphasizing automation and policy enforcement to reduce the risk of human error and ensure continuous adherence to security standards. It directly addresses the risk of drift by embedding security into the operational fabric of VCF. Incorrect approaches analysis. One incorrect approach involves relying solely on manual security reviews and ad hoc vulnerability scans after new services are deployed. This is a reactive strategy that is inherently prone to delays and oversights. It fails to address the root cause of the risk, which is the potential for insecure configurations to be introduced in the first place. This approach also increases the likelihood of security gaps remaining open for extended periods, thereby increasing the attack surface and the potential impact of a breach. It also fails to meet the spirit of continuous compliance and proactive security expected in modern cloud operations. Another incorrect approach is to disable or bypass security controls for newly deployed services to expedite their availability. While seemingly a quick fix, this creates significant security risks. It directly contradicts the principle of least privilege and the need for consistent security enforcement across the entire VCF environment. This approach introduces known vulnerabilities and compliance violations, making the environment susceptible to attacks and regulatory penalties. It prioritizes speed over security, a trade-off that is rarely justifiable in a professional IT context. A third incorrect approach is to assume that the default security configurations within VCF 5.2 are sufficient for all new services without further assessment. While VCF provides robust default security, the specific requirements of different applications and workloads can vary significantly. A one-size-fits-all approach to security is rarely effective. This method fails to account for the unique security needs of diverse services, potentially leaving them underprotected or overprotected in ways that impact performance or functionality, and most importantly, failing to address specific compliance requirements that may necessitate tailored security measures. Professional reasoning. Professionals should adopt a defense-in-depth strategy that integrates security into the entire VCF lifecycle. This involves understanding the security and compliance requirements of each workload and service before deployment. Leveraging VCF's automation and policy-driven capabilities, such as NSX security groups and firewall rules, is crucial. Regular audits and continuous monitoring, coupled with automated remediation where possible, are essential to maintain a secure and compliant environment. The decision-making process should prioritize proactive risk mitigation through automation and policy enforcement, ensuring that security is not an afterthought but a fundamental component of service delivery. Question 19. Analysis of the security implications of deploying new services within a VMware Cloud Foundation 5.2 environment, specifically concerning network segmentation and access control, when faced with pressure to accelerate deployment timelines. Option A. Deploy new services without a formal security review or impact assessment, assuming that the underlying VCF infrastructure provides adequate protection. Option B. Conduct a thorough review of the VCF deployment against VMware security hardening guides and relevant industry best practices, focusing on granular network segmentation and strict access control policies before and during the deployment of new services. Option C. Implement broad, permissive firewall rules to allow all inbound and outbound traffic for new services to expedite integration and minimize initial configuration overhead. Option D. Rely solely on the default security settings provided by VMware Cloud Foundation 5.2, assuming they are sufficient for all new service deployments without further customization or validation. The correct answer is C. Implement broad, permissive firewall rules to allow all inbound and outbound traffic for new services to expedite integration and minimize initial configuration overhead. Explanation. Scenario analysis. This scenario presents a common challenge in cloud administration, balancing the need for rapid deployment and feature adoption with the imperative of maintaining a secure and compliant infrastructure. The pressure to deliver new services quickly can lead to overlooking critical security configurations, especially when dealing with sensitive data. The administrator must navigate the inherent tension between agility and security, ensuring that the VMware Cloud Foundation (VCF) environment adheres to established security baselines and regulatory requirements without unduly hindering business operations. The challenge lies in identifying and mitigating risks proactively, rather than reactively, which requires a thorough understanding of VCF's security posture and the potential impact of misconfigurations. Correct approach analysis. The correct approach involves a systematic review of the VCF deployment against the VMware security hardening guides and relevant industry best practices, specifically focusing on network segmentation and access control. This aligns with the principle of least privilege and defense in depth, fundamental tenets of cybersecurity. By ensuring that network traffic is restricted to only necessary ports and protocols between VCF components and external services, and by implementing robust identity and access management (IAM) controls, the administrator significantly reduces the attack surface. This proactive security posture is not only a best practice, but is often mandated by regulatory frameworks that require organizations to protect sensitive data through appropriate technical and organizational measures. Adhering to these guides ensures that the VCF environment is configured to meet compliance obligations and minimize the risk of unauthorized access or data breaches. Incorrect approaches analysis. Implementing a broad, permissive firewall rule that allows all inbound and outbound traffic for new services is a significant regulatory and ethical failure. This approach violates the principle of least privilege, creating an open pathway for potential threats and unauthorized access. Directly contravenes regulations that mandate data protection and secure network configurations. Ethically, it demonstrates a disregard for due diligence in protecting the organization's assets and data. Deploying new services without a formal security review or impact assessment is another critical failure. This bypasses established security protocols and increases the likelihood of introducing vulnerabilities. It suggests a lack of adherence to organizational security policies and potentially to regulatory requirements that mandate risk management and change control processes. This can lead to compliance violations and reputational damage. Relying solely on the default security settings of VCF without customization or validation against specific security requirements is insufficient. While default settings offer a baseline, they are rarely optimized for all environments or specific compliance needs. This approach fails to address potential gaps and leaves the environment susceptible to known or emerging threats, which can result in regulatory noncompliance and security incidents. Professional reasoning. Professionals should adopt a risk-based approach to VCF deployments and ongoing management. This involves understanding the organization's security and compliance obligations, identifying critical assets and data, and then designing and implementing security controls accordingly. A structured process for evaluating new deployments, including security reviews, impact assessments, and adherence to hardening guides, is essential. Regular audits and continuous monitoring of the VCF environment are also crucial to identify and address any deviations from the desired security posture. When faced with pressure to deploy quickly, professionals must advocate for a balanced approach that prioritizes security and compliance, leveraging automation and well-defined processes to achieve both agility and robust security. Question 20. The efficiency study reveals that while one network segmentation strategy significantly reduces intersegment traffic latency, another strategy, though introducing slightly higher latency, provides a more robust isolation of critical workloads from less trusted zones. Considering the inherent security posture of VMware Cloud Foundation 5.2 and the principle of defense in depth, which approach to network segmentation is most aligned with professional best practices for a production environment? Option A. Focus on a strategy that minimizes the number of network segments to reduce management complexity, even if it means less granular isolation. Option B. Adopt a hybrid approach by implementing the lower latency strategy for non-critical workloads and the robust isolation strategy for critical workloads. Without a clear overarching policy, Option C. Prioritize the strategy that offers the most robust isolation of critical workloads, even with slightly higher latency, as it aligns with security best practices for limiting the impact of potential breaches. Option D. Implement the strategy that significantly reduces intersegment traffic latency, as performance is the primary driver for efficiency in a cloud environment. The correct answer is C. Prioritize the strategy that offers the most robust isolation of critical workloads, even with slightly higher latency, as it aligns with security best practices for limiting the impact of potential breaches. Explanation: the efficiency study reveals a significant disparity in the performance of two distinct network segmentation strategies within a VMware Cloud Foundation 5.2 environment. This scenario is professionally challenging because the administrator must not only understand the technical implications of each strategy, but also how these implications align with the security and operational best practices mandated by VMware's own documentation and general IT governance principles, which are implicitly part of the exam's scope. The choice impacts not only performance, but also the ability to isolate threats, manage compliance, and maintain service availability, all critical aspects of a VCF administrator's role. The correct approach represents best professional practice because it prioritizes a holistic view of network segmentation, considering both isolation effectiveness and operational overhead. This aligns with the principle of least privilege and defense in depth, ensuring that security controls are robust without unduly hindering legitimate operations or introducing unnecessary complexity. Adhering to VMware's recommended practices for network segmentation, such as leveraging NSXT capabilities for microsegmentation and logical network isolation, is paramount. This ensures that the chosen strategy is not only technically sound, but also supported, documented, and likely to be compatible with future updates and integrations within the VCF ecosystem. An incorrect approach that focuses solely on performance metrics without considering security implications represents a significant regulatory and ethical failure. It neglects the fundamental purpose of network segmentation, which is to limit the blast radius of security incidents. This could lead to a breach in one segment easily propagating to others, violating security policies and potentially compliance mandates. Another incorrect approach that overcomplicates segmentation by creating an excessive number of granular segments without a clear operational benefit introduces significant management overhead and increases the likelihood of misconfiguration. This can inadvertently create security gaps or disrupt legitimate traffic flows, undermining the intended benefits of segmentation and potentially violating operational efficiency guidelines. A third incorrect approach that relies on outdated or unsupported segmentation methods ignores the evolving threat landscape and the advancements in VCF and NSXT, leading to a less secure and less manageable environment. The professional reasoning process should involve a thorough assessment of the VCF environment's specific security requirements, compliance obligations, and operational needs. This includes understanding the data sensitivity within different workloads, the potential threat vectors, and the acceptable levels of operational complexity. A structured approach would involve 1. Defining clear segmentation objectives based on security and compliance needs. 2. Evaluating available NSXT features and VCF best practices for achieving these objectives. 3. Considering the operational impact, including management, monitoring, and troubleshooting. 4. Selecting the strategy that offers the optimal balance between security, performance, and manageability, with a strong emphasis on adherence to documented best practices.